indices. I really don't like the word indices, so, and I've seen people write indexes. Makes sense to me, but especially for programming, when you have plurals, you want something just that adds to the end instead of having to delete and retype stuff. I used to call them indices, but then I realized I was just being dumb. Okay. So another thing we should probably do here is increment them. So let's just do it. M window A sample plus plus. Yeah, that's fine. And we do M. Oh, we can't plus plus because that's a float. Yeah, so we need to, here is where it gets tricky, because the sample has to take into account the speed factor. Right. M window A sample plus equals 1.0 times 1.0 divided by M stretched rate. Yeah, this will move the A sample down at the correct speed. And we don't need that initial 1.0, obviously. And we don't need those parentheses now. And that's a float, so it'll do the right thing. Now, yeah, the thing is, this is where we check the sample. So this is where we check the buffer, the filter buffer. And those were the blue items that are a third element, the third type of window-like structure. So this is where we have to make sure we haven't stepped over it. So we just say if M window sample is greater than and window sample greater than what do you call it? Window A. No. Yeah, M window A index. And we want the delay buffer like that. And there's probably a size. There's a size, right? Num frames. That's why it's nice to have copy and paste. You get the stuff right under. You just have to remember to delete it and change it. Yeah, my throat's not doing so well today. So, M window sample is greater than the number of frames. Even if it's equal to the number of frames, we need to do something. Yeah, and so we'd assume that we round down normally when we use it. And this kind of notation does mean round down. So, what we can do is simply increment when we've hit that mark. Now, we don't want to subtract necessarily. What we want to do is, we don't want to set to 0. What we can do instead is do this minus equals. And this will take care of the remainder. Just 1 second. I have to pet my dog. What are you doing, dog? What are you doing, dog? Go to sleep, dog. Go to sleep. Alright, the dog has been pet, and we can write the next line of code. Yes. So we want to subtract exactly the number of frames. And this should get pretty close to 0 every time. So this is relative to the delay buff. So make sure it stays in the bounds, or increments, or moves to the next buffer. Yeah, so when we do this, after we've incremented, resetted that counter, the index can also increment, right? Yeah. The other thing is, yeah, we don't need any of that, I don't think. Yeah, and every sample, this gets called once a sample. This for loop happens once sample. So the other thing we need to do is increment the A index. Like that. And then we're good, right? When we're here, though, we would want to make sure that we haven't gone over. So what I mean is this. This should be less than the number of buffers. And we can recycle this wisdom for the A window. We just have to remember to change all the B's to A's. In this case, only 2. Yeah. So that looks like all we need. I mean, we can refactor this in just a bit, because you can see how much duplicated code there is. And once we refactor it, it's not only pretty, but we can modify this easily to scale up to 3 buffers or more. That is going to be nice. Yeah. So let's verify that our initial conditions will work. I'm going to kill that and look at both parts of the code at the same time. So the initial conditions are that the B index starts at negative something. Yeah. Yeah, right. So what we can do is, this is only for B, so for now we'll need some kind of hack, like if we can move this up to the top, like so. Ooh, did that not get changed to B? So we also need to mod the A table index. So this has to be reset to 0 when we're done with the window. Like that. We could just do a mod as well, that's true. It's a little cleaner, code-wise. Although for negative values you don't want to do mods. That's true, right? I know I've run into values. I can't remember if it was only this side. If this side's negative, you're screwed. But I think if this side's negative, it's still undefined. I'm not sure. I mean, logically, it wouldn't be, but if it's undefined, even if it's easy to implement, you can't rely on that. Yeah, I'm going back, because this is guaranteed to work. I don't know if stretch has a T here. I don't think it does. So the initial case is still tricky. Even if we increment here, yeah, we can really just hack it. Like, if this is 0, no. Yeah, so we do the same deal. But we do the extra hacky business of seeing that, oh, we have a negative B index. Well, if just less than 0, we also increment that. I think, yeah, there's probably a much cleaner way to do this. But hey, this makes sense. It's not horrible. And we only want to do the other window sample incrementing once we have no, but it needs to be in a reasonable place. Yeah, so when we reset the state up above, the sample needs to be in a reasonable place. And the initial sample, if we go back to our drawing, is, yeah, it's somewhere out in front of the first sample. Yeah, so we'll say, ooh, that's hard because this should really be up ahead. Ah, that is so hard. So we have to essentially convert window index, you know, our table window index to buffer window indexes, which sucks.